Okay, so here's some simple kinds of problems we can do without having a bunch of other properties. We just have those two basic inverse function properties. We can, this typical kind of, they're just exercises to get used to manipulating logarithms. So it says, number one here, write as a logarithmic equation, 3 to the 4th equals 81. Now, that's just a true statement. 3 to the 4th is 81. So you're not trying to solve for anything. They just want you to write it in a different form, in a logarithmic form. A logarithmic equation is an equation that has a logarithm in it. So how do you get a logarithm in it? Well, you just look at the base of that exponent part, the 3 to the 4th, the base is 3, and you take a log base 3 of both sides of the equation. This is a smart way to do it, okay? Take log base 3 of both sides. It's a smart way because you're using the properties that you know are true. So log base 3 of 3 to the 4th, the log base 3 and the 3 cancel. So you just, on the left you get 4. Right? You get 4 equals log base 3 of 81. So it's that simple. Don't just move numbers around with this. Actually do the log base 3 with these. Okay, here's another example. Write as an exponential equation. So that means that you'll have some power in there, right? Log base 2 of 1/8 equals -3. Well, what's the inverse function of log base 2? It's exponential function base 2. So you have to compose both sides of the equation with exponential function base 2. What that does is it just puts these two items in the exponent with the base 2. So you just write a 2 here and a 2 here. And then this 2 and the log base 2 will cancel, and you'll get 1/8 on the left. So we're taking the exponential function base 2 of each side of the equation. Put the 2 in the base, and the original left and right sides will end up in the exponent. This is, sometimes people will say logarithms are exponents, and this is what they mean. They often, when you're solving things, they end up in the exponent because you're trying to get rid of the log. So 2 to the log base 2 of 1/8 equals 2 to the -3. So compare this and this. You can see what I did. I just stuck 2's in the base and put these in the exponents. Then these cancel, so the left side's just 1/8. And so it says 1/8 equals 2 to the -3, which is true, but that's written in exponential form. Okay, so you're just going back and forth. Write this logarithmic equation as an exponential. Write this exponential equation as a logarithmic equation, and write this logarithmic equation as an exponential equation, both ways. It's just practice using the properties that we had on the previous video. So solve. Log base 7 of 3x equals -1. Well, to solve this, I want to get rid of the log base 7 because I don't know how to solve things with log base 7 in them. So how do you do that? Well, you use the inverse function, which is exponential function base 7. Compose both sides with that, which just means you take these quantities, this one and this one, the left side of the equation and the right side of the equation, and they both go in exponents with a base 7. Like that. Then these cancel off. These two cancel off, and the left side will just be 3x. So then it says 3x equals 1/7. And then you cross multiply the 3. Goes on down on the bottom there. And you get x equals 1/21. You can check, but you can't really check with a calculator until you know more but you can plug it in if you understand how things work. So that's log base 7 of 1/7, write 1/7 as a power of 7. So that's 7 to the minus 1, and then those two cancel and you get minus 1, which is what we were supposed to get here. Okay, that's also good practice, checking them.